No problem. Yeah.
Start whenever you'd like.
Sounds great. Hi, everybody. Thanks for joining us after lunch. Hope everybody had a good lunch and is ready to talk about graph search. All right. So my name is Janko Ivanov. I'm a senior consultant, knowledge management consultant with Enterprise Knowledge. I've been working in the KM's area for the last 10 years or so. But lately, in the last couple of years, I've been focusing on semantic technologies. Semantic technology is ontology, graph databases. So today I wanted to show you and discuss with you a little bit of the benefits of graph database, graph-based knowledge discovery. How do we find knowledge that we don't know exists in our data sets or external data sets that are integrated with our data sets? So with that, what we'll talk about a little bit today is why graph search? What does it benefit us compared to traditional search? Then a little bit about knowledge graph, just to level set with everybody what a knowledge graph is, what it does, what it looks like. And then how does it all fit together from ontologies, taxonomies, knowledge graph, and then graph search? How do we get it to work together so we have one cohesive view of the data, of the information that we have? And then we'll switch to a demo, basically a business case and a demo of a specific tool that we've worked with recently, and they put together a use case for an HR system. This is not a live system, but it's going to give you the full view of, from the beginning to the end user, how we integrate different data sources, structured and unstructured data, so that we provide this one cohesive view of the information, so you can extract facts that you may not know otherwise. All right. So why are we talking about graph search? We all have used Google. We know Google, the way Google works. On the right side, on the left side, rather, you have the traditional search. You have where the strings, the regular search results. And on the right side, you usually have a box, info box, where a concept for what you're searching for, let's say I'm searching for Leonardo da Vinci. If Google recognizes that I'm searching for a specific person or a specific concept, company, or whatever it is, it will put that box a little bit to the right, and it will give me all the information that is related to that concept. Whether it's, for example, if it is Leonardo da Vinci, date of birth, when it was some of his paintings, basically the information that is related to the concept, in this case, person, Leonardo da Vinci. So what graph search does is exactly this. We are able to get all the information about one thing, whatever that thing is, whether it's a person, a place, or a concept, and display it in one cohesive way, regardless of where this information is coming from. So as far as graph search, we're taking the regular traditional search and we start talk about cognitive engines, cognitive search engines, question and answer. Nowadays, we're so used to go to Google and say, tell me this and this and this, basically pretty much put the whole sentence, and we do get the result. That is graph search, is based on graph search technology. Same with recommender systems. The recommendations engine behind a regular recommender system is usually based on a graph database, on a graph knowledge graph, which provides all the relationships between different concepts. Now, also, we're moving from more of a document-centric retrieval, the traditional search. I'm searching for this document. I know what to look for. I'm searching for it. Or I get the results based on a specific string. Now, with graph databases, we're moving a little bit more toward entity search, entity-centric. Like Leonardo da Vinci, the example I just gave, this is an entity. It's a person. The machine understands that. So the machine knows what the properties are behind an entity of type person. So it's not about strings anymore. It's about things. So it's something that the machine can understand as well as a human can understand. An additional piece behind knowledge graphs is the knowledge discovery. We have the knowledge graph, and like I mentioned earlier, we can integrate different types of data, whether it's a structured data from a database specifically, or an Excel spreadsheet, or XML, regardless, or a content from our content management system, SharePoint, Drupal, and so on, we can integrate this into one cohesive view So now we can run different kinds of analytics than just on what we used to have to be able to do it in only SharePoint, for example. So this is where we start discovering new knowledge, new facts. And then the last piece here is it is the basis of recommender systems. When you go to Netflix, for example, you have all these recommendations. They're based on knowledge graph based. They're based on various attributes. Depending on what you've seen so far, how does that map to other movies that are there? All right. So with this, I mentioned knowledge graph a couple times already. So a knowledge graph, what it really does is provides the relationships between things. So with EK, the way we define it is a linked data store that organizes structured and unstructured information through entities, their properties, and the way they relate to each other. So in this case, a project is a type of entity. So sales process redesign could be a project. So that project itself has attributes. It could be the project manager. It could be start and date. This is an attribute. But it's also related to other concepts. Employees, Bob Jones is working on this project. So there is a relationship between the type person and the project. So this is the way we basically build this knowledge graph, enterprise knowledge graph, based on the knowledge, the domain of that organization. Whether it's a consulting company with projects and clients, or a construction company, or whatever type of company it is, it really is focused on the domain for that company. Yeah, please. It's very closely related. I believe we can do that as well with knowledge graphs. I'm not sure about the social networking part, but I know that Facebook is using the knowledge graph as well. The same exact way. A person, me and my friends, there are specific relationships. So yes, we can traverse the different relationships between people. Same thing here. You can easily traverse from project. You can define the employee, and that from the employee you can see, for example, different teammates from that employee or different projects that person has worked on, and you can easily traverse the network. And the recommendations, additionally, the recommendation engine usually is based on comparison to how closely related you are to the different entities, right? So if you have one entity, what are the immediate vicinity entities? So and then you can easily go forward. Right.
Isn't that also a bit like access then?
Like access? Now we're talking about relational databases, right? Access, SQL Server. This is a relational database. So yes, there is similarities, but this is a little bit different because this is not as restrictive. With graph databases, you can build a graph database in a very agile way. You start small, and this is actually one of our best practice recommendations. You start small, defining these entities, whether it's a person, whether it's a project, and then you can define the attributes, but also an attribute later can become an actual concept. Like, for example, I mentioned for a project, you can have a project manager. Technically, that is a person, so that should be a concept in itself. But you don't have to start with the people right away. So that's the one of the benefits behind graph databases. Once you define that model, you can easily extend it later because you add more data sets. They may have different concepts, so you can easily model them going forward. Make sense? There are other relationships between relational database and graph database, and we can talk about it offline. But make sense so far?
Yeah.
All right. Okay, other questions on graph databases? All right. So now, and the next slide may look a little scary, but this is the most technical I'll get to. I just wanted to give you a high-level overview of the whole process of getting the data, classifying it, auto-tagging it, and getting it into one user interface. So what we start here, the first part on the left is the taxonomy and ontology server, or having the dictionary, your vocabulary for the company, for the organization. You need to have this defined so that whatever you're using as a artificial intelligence or machine learning algorithm, it can recognize your language, your concepts. You need to teach it something, right? So this is what we start with, your vocabulary, your basic vocabulary. And I'll show you a basic example of that. But there is a little bit of a cycle here. So we start with the vocabulary, then we feed this engine our content, which is this little box here in the middle. The engine analyzes that content and says, okay, I recognize this concept, I recognize that, but I'm also seeing these other things that I don't recognize what they are specifically, but I think they're important. What do you think? So this is providing the knowledge engineer a feedback loop where we can expand our vocabulary. We can define it specifically. So the engine it becomes smarter and smarter over time. Okay, great. So this is good. So far, we've identified things in our content, but that doesn't really help us so far. What happens next is, and we'll see a quick demo of that as well, is applying these tags to the content. Applying the tags so we can filter on this specific content. We can search for similar things based on these tags as well. And then the next piece, once we apply the tags, we can also put them in this relational database, or graph database, not relational database. The graph database is where we basically store the relationship between an actual document and its tags, for example. And same thing here. The next piece is the integration of the data, the different data sources, whether it's the content management system or the relational database or XML or other structured data. We extract that data through the schema mapping based on ontologies and the unified views component of Pool Party. If you haven't heard Pool Party, we'll talk about this in a second. This is a tool that we're using for this extraction, machine learning, and the graph database, or rather the graph search. So we take this and we put it all into the graph database based on this ontology map. So it's all in here now, or links to it are all in here. So this is now our database where we can use analytics, which is really what the graph search is for. It provides analytics. It provides this unified view of all your information. Now, when I say graph database, this is not our system that has all the data in it. It has relationships to the actual data. We still have SharePoint. We still have Drupal and our databases. They're still there. But we have relationships to the data in these systems. We don't want to retire these systems. The idea here is we still leverage these systems as the system of record because they have functionality that we may not provide necessarily through this graph search. This may be focused on a specific use case, but you still want to keep your customer relationship management system and so on. So the idea is you're providing links to all your data in one place. Makes sense? Any questions on this one? Yes?
Sort of a practical question.
Yeah.
Sounds really great. But in our systems, we have permissioning.
Right.
Right? So only certain people can see certain things. So
Absolutely.
How does that interplay with that? I'm assuming that functionality remains, that if you're doing
It does.
a broad search and it's pulling in from the different sources, I as a searcher will only see things that I have permission to see.
Absolutely. So this is also, yes, this is also part of the graph search or your end user application. The information about access permissions is also going into that database. So if you have a specific item, you can have attributes for this item. Who can see it? What groups can see it? So it depends how you model this, but yes, it's definitely something that is important.
What's the difference between the unified view and the graph database?
Right. So the unified views, and this is not the focus on this discussion today, but I'll give you, so because it's pretty technical. The idea here is it acts as your orchestrator to get the data from the different systems and pull it into the graph database. Basically, let's say you go to SharePoint, you do the tagging, you have different pipelines that really feed into the graph database as in RDF format. RDF is a standard from the W3C. It's just a way of representing the data for the graph database.
So that traditional knowledge, it would just go from the unified view over to the screen, right? Skip the graph
in traditional, you maybe just with SharePoint, right? So you don't, this would be your SharePoint search, depending how you implement it, whether it's a search or recommendation engine in SharePoint, if there is another way of implementing it. But this is really looking at the comprehensive view of your information. All right, good so far? All right, so let's take a look at the business case real quick, and then I'll jump into the demo to show you what this really looks like. So the use case here is we're talking about an HR system. How do we, and there are different challenges that an HR person has to deal with. Your recruitment efforts, what are they based on? How do you know who you need to recruit? Is it somebody that the project managers come and says, hey, I need this person with machine learning skills and so on, and then you panic to find that person? Or do you really work on based on data? So we'll take a look at that. Also, training and development. How do you know what kind of training do you need? If you're a company in a specific field, do you have the skills for that field? Do you need to expand the skills? So we'll take a look at that as well. And some questions, for example, which employee has skills in areas where demand is increasing across the industry? Or who on our staff should we look into to acquire new skills? So I'll explain this a little bit more, but the idea here is if you have trend analysis from an external source about how are skills trending, for example, machine learning. Machine learning is probably a skill that is going up in the recent years. So do you need a person with that skill or not? And then as far as data sources for this use case, we'll take a look at your typical document management system, SharePoint, or content management system, whatever it is, right? Unstructured data. Then we'll take a look at also an HR export. In this case, it's an Excel spreadsheet with user prof or specific metadata fields, and as well as their resumes. And then the last piece is a third-party database. In this case, again, it's a structured data that for this use case is extracted from a third-party source, providing this kind of trend analysis for skills demand. So we'll take a look at that as well. As far as the demo, as far as the technology behind the demo, we'll be using PoolParty. PoolParty is a semantic middleware provided by the Semantic Web company, and they're marketing this as a search recommendation analytics fusion. It really does all these things when you get to it. So as far as this demo, what I wanted to show you is the whole process, all in one, really, all end-to-end showcase of what we're starting with, the raw data, to getting to the analytics. So as far as the technology, we'll take a look at the PoolParty taxonomy server very quickly. Unified views is what is, like I mentioned earlier, this is what we use to get the data into one location. And then graph database, in this case, is a Mark Logic. But graph database can be pretty much anything that is based on RDF standard. And then the last piece is the PoolParty graph search. All right, so with this, I will switch to, OK. All right, so pardon me if I sit here, because it's going to be a little bit easier to talk and look at what you guys are seeing as well. So what we're looking at this, remember how I was talking about the vocabulary, the vocabulary for your organization. So this is the front end, and this is very out-of-the-box front end from PoolParty. This is very customizable, but the idea here is it shows you your vocabulary. So in this case, on the left side here, we have the company type, job roles, the high-level facets, if you will, or attributes. Then if you click on each of these, it will give you the details of each of them. So I clicked on job roles. Yes, absolutely. Good point. There you go. Better? OK. So with job roles, we have different ones. It could be IT. It could be knowledge engineering experts. And like I said, this is just for demo purposes. This is not exhaustive list. Each organization may have slightly different set of roles. If we look at skills, so the skills here, and we have the concept ID. So one main piece behind knowledge graphs is that each item has its own unique ID. In this case, this is an URI. So you can refer to it from external applications easily. You know exactly what you're getting, and it's right there as well. So looking at top concept and creative, we don't have to get into specifics, but the idea here is in the category skills, we have several. It could be language-specific skills. It could be operating systems. Let's take a look at the operating system one. And it has, well, in this case, it's an alternative label for OS. And then we have a list of operating systems right here. So this gives us an example of the basic vocabulary. Obviously, when we get into an actual organization, this could be much more extensive. And obviously, the more extensive, the more expressive, the better. So you can really find what you're looking for. Right. So with the next step, so now that we have the vocabulary, let's take a look at our content management system, content or document management system. In this case, this is SharePoint. What we've done already, and now let me zoom that in. So this is the HR site for a fictional company. We have all the resumes for all staff. And based on the resumes or the CVs, we've used the extractor for Pool Party to analyze the CV and extract the information that it can detect, the tags that it can detect. So it's a little difficult to see, but let me see if I can make it a little bigger. So we have different tags. In this case, Bachelor of Engineering, Computer Science, Data Mining, different things that we could recognize what they are. So we tag this person or this resume with these tags, and in SharePoint, you can easily this is just a quick example of SharePoint, how this works. Clicking on data mining can give you all people with data mining in their tags as well. So this is a quick filter within SharePoint itself. This is not even graph database at all yet. So this is just applying tags within SharePoint and being able to see somewhat of a similarity there. An additional benefit for SharePoint by doing this is this power search. This is provided by the component of Pool Party that integrates with SharePoint very natively. And what it does is provides you the facets based on what we have as a vocabulary, and you can filter on different results based on these facets. All right, let's see what happens. Okay, so in this case, I haven't searched for anything. Let's say machine learning. And you can see it gives me recommendations. If I start typing for machine learning, it can give me the recommendation of the specific concept that we know, what a machine learning is. So if I click this, which is in research focus, it will give me everybody that has machine learning as part of their tags for their resumes. This is really SharePoint, native SharePoint functionality with Pool Party. This can be customized. You can provide more information in terms of the metadata tags, in terms of, oh, and this is on the right side here. I'm not sure why it's not showing there, but on the right side, let's see, is what I was referring to earlier as this info box. In this case, the machine here really recognized machine learning. I know what this is, and I'll show you what I know about it so far. In this case, it's more general. It's a research-focused field and has some relationship in terms of what the parent of this term is, what the children are. But this could easily be a more extensive list of information. It could be relationship with specific people. It could be relationship to projects that are focused on machine learning. There could be a specific image as well. And we'll see that in the graph database. All right, so, and on the left side, you can see that, okay, so these are, again, you can see the skills, machine learning, programming, and so on. These are the filters that we've already defined as our vocabulary, right? These are the refiners, as SharePoint puts them, that we can, again, filter the specific results that we're interested in. So this is already quite a bit of an expansion on what SharePoint out of the box can do. So this is already a benefit. However, moving on to the next piece. So far, we've seen the unstructured data. And actually, let me show you. Well, I'll probably have it here. I was going to open a document. Let me open it in from here. OK. So what we're looking at here, this is the actual structured data. Again, HR, again, from the fictional company. These are all the employees with specific attributes for them. This is very structured data. We have, let me make this slightly bigger. We have the name, age, job title. Again, that's very closely related to the vocabulary that we already have. Gross salary and link to the CV. And opening that. There you go. So this is just an example of what a regular CV would look like. It's a Word document. This is very common for pretty much any company. You have objective education, professional experience, as well as skills. This is what, in the previous step, this is what the extractor looked at to identify these items that we already know about. And obviously, keywords as well, that helps, like object maker, PHP, Perl, and so on. All right, back to this. So far, this is pretty straightforward, but as of now, these are two completely separate data sources. There is no way for us to really relate them very easily and run analytics on them. Now, to make things even more interesting, there is yet another data source. Again, it's structured data source, but it's a separate data source. This is an external data source. Let's say you have a subscription to an organization like LinkedIn that can provide you trend analysis on all kinds of information. And specifically to HR, what people are interested in, what is the interest level in different skills or different jobs positions. So what we're looking at here really is a simple extrapolation of between 2015 and 2016, how the popularity of each of these skills increased or decreased. So pretty straightforward, but again, this is an external source. We can get it as an Excel if we're lucky, or we can get it as an API call. There are different ways of getting that data. But as long as we can get it, we can get this data into our graph database using unified views to just transform this data into the RDF and not only transform it, but also apply the tags that we already have. So what this would do is identify that when we're looking through to this data with the unified views process is, okay, we're looking at languages. We're looking at English, Chinese, Japanese, Spanish. These are things that our graph database knows about, so we can easily tag them with these specific items. So this is how we relate multiple different things to the item English. So at the end of the day, in the graph database, when we have an item concept English, the label is English, but it has multiple different things related to it. It could be different data sources. So when we look at people with English skills, we can easily see the different sources of that data. And I'll show you that exactly in the next view. Now, over here on the next tab is project database. This is still in progress as part of this use case development. But the next step would be, how do we relate people to projects? How do we find people with specific skills for that project? What would be a good project for Janko, for example, to be on based on Janko's skills? OK. So far, everybody with me? Makes sense? All right. So the next piece is the graph search. And while this may not be as exciting as Google, for example, the idea here is to show you what the capabilities are. This is out-of-the-box functionality from Pool Party Graph Search. So it's not specifically customized in terms of look and feel, but we have easily customized what kind of facets we show on the left. And this is based on the HR demo. Can you guys see it okay? The HR demo. This is our graph database for this specific use case. We're talking about HR. But as part of, of a larger company, this could be much bigger, much more different, many different use cases. It could be the projects database, for example, the projects graph. It could be something else that is a little bit more focused on what you're looking for. So in this case, it's HR demo. If it was a little bit later in the day, we could talk about cocktails. But let's stick with HR. All right, so these are the things that you've already seen, right? These are the things that we've defined as our vocabulary in the taxonomy. So the system, the graph database, the graph search rather, picks those things up automatically and allows the end user or the knowledge engineer to define what shows up here based on what this use case is about. So like I said, it's very easy to just select or deselect some things. I've deselected entity types because this is really doesn't matter for this specific case. But if I don't care about salary, I can easily remove it. Okay, so this is the full set of employees within this fictitious company. I can easily search on things, or I can just filter to find the different sets of information that I'm looking for. So we were talking about, one of the questions was, how can I identify people with skills that probably should look at improving their skills or potentially acquiring new skills? Let's take a look at technology domains, let's say. One thing, and I'll switch back to the data real quick and to show you what this is. Mild positive growth versus very positive growth. What this is, as part of the transformation of the data source that we're getting outside and putting into our graph database, in this case, we decided, okay, we want not just a specific number, we want to classify this range of percentages, which is what we were looking at here, the growth rate. We can classify them in 6 different things. It could be slightly negative growth or slightly positive growth, so it's easier for people to understand or just classify. So this happens in the back end, and it's a part of that transformation process. So what we see here is really the user-friendly way of seeing that. And the number here on the right shows how many, in this case, people satisfy that specific thing. How many people are tagged with this item? So we said we are looking to see people with, let's say, salary. I'm looking for lower growth. Well, maybe not technology. Let's take a look at tools. Medium negative growth. Okay. So in this case, I'm looking at. So we're looking at the filter medium negative growth. We have a couple of people that, based on their skills, the growth level of their combination of skills is slightly negative or medium negative. So let's see what that means. If we take a look at technology domains now, bioinformatics. Okay, so bioinformatics for Elena seems like this is a skill that may be at risk. If this is something that bioinformatics, for example, may be going, it's not as popular anymore, maybe Elena should start looking into how can we expand this kind of skill. Or acquire different skills so that she's still marketable, she's still very valuable for the company and so on, and obviously for personal development. Let's take a look at a different example. Okay, so let's clear those out. Technology domains. If we're sticking to technology domains, artificial intelligence. Okay, let's take a look at artificial intelligence and at the same time look at salary. So if we're looking for experts with artificial intelligence that are, and we know that artificial intelligence is pretty high in terms of very positive growth, then let's take a look at people that are on the lower scale of our salaries. That may tell us that, okay, they are with skills that are in high demand, but we're not paying them very much. So are they at risk at leaving the company? So this gives us information based on these cross variables. And again, you can see the cross variables coming from the different data sources. So this is a set of people that we should potentially make sure that they're happy, that they're getting what they're looking for, and so on. So to get a little bit more information, let's look at a specific data for Elena. What we are seeing here is really the unified view of a user profile, of an employee profile. When I say unified, that is what we were talking about from the very beginning, right? Including this information from the various different sources. This is the description. In this case, is really the resume that we have on file. And obviously, this is not formatted quite as pretty, but that's also something that it can be configured or developed a little bit better. So going further down, we have the specific metadata fields that or metadata fields and attributes that we know about this person. And you'll see some of these are coming from machine learning. This came from the HR database, the job title, the research focus. Salary also comes from that database, the HR database. Technology domains is likely coming from Elena's resume. This is based on what we tagged the resume with. Tools, same thing. We may have a specific section in the resume that talks about the tools, but it could be throughout the resume. As long as the system tags the resume with that tool, it's there. And additionally, you'll see this piece. This piece is what we talked about in terms of the external data. How do we classify her skill set for Salesforce? In this case, it's, mildly positive growth. Salesforce is on the uprise. It's been like that for a while. So this is telling us something in terms of, she's doing good in terms of these skill sets. She's a wanted resource. Age, that's pretty straightforward, but again, this is structured data that's coming from a different source. Gross salary, job title, link to the CV. And this is where we can actually provide the link, again, to, in this case, the Google Drive. You see, we had a link to the CV in the SharePoint. In this case, it's a link to Google Drive. This was specifically done for this use case so that we actually have access, so we can open it. But it can be in real life. How many places, how many companies have various document management systems with similar content all over the place? That's a pretty common example. So that's where we can really get things together and show some duplicates or even provide additional information. All right, so this is the user profile, and you see the picture. The picture came from that specific URL from the HR database, or it could be an HR system. It could be from anywhere. As long as we have a consistent way of getting that URL, we can use it to really put the profile of the employee in one place. All right, the next piece here I wanted to show you is the recommendations. So let's say we've looked at Elena, and based on a specific recommendations engine and algorithms, we can get recommendations for people with similar skills, with similar salary range, or whatever it is that we are interested in. In this case, it's graph similarity. So this is relatively technical piece, but it's what we were just talking a little bit earlier about how close these nodes are related to each other in the graph itself. So it could be different algorithms, really. It could be, again, a recommendation based on the different attributes. OK, and the last piece I wanted to mention is another recommendation. And this is the next piece Pool Party is working on. And this part at the bottom is really, OK, so now that we have the full profile of an employee in one place, what do we do with it? Other than doing the analysis on the attributes that we already saw, what is the next step? Like I mentioned earlier, recommending projects where Elena would really fit well based on the information that we know for her and what this project is about. This requires a project description, and maybe some other attributes, we can make this recommendation of fit, right? So this could be one way of doing this. And there are many other options of providing recommendations and leveraging that profile for really data analytics. Okay, so I think this really gives us this holistic view of the information that we just talked about a little bit, from the data dictionary or the taxonomy and dictionary that we have, through the analytics, machine learning, and AI and text analytics, to integration of all this data into one place, and then doing the actual analytics of that data on a human level, on a really subject matter expert level. This is about it for the demo. Any questions so far? Does this make sense? Do you guys see, and I'm really looking for some feedback, do you see the usefulness of this on a day-to-day basis in the organizations where you work with? And do you have any questions for me? Yes, sir.
Would that system
Yeah.
be capable of working with existing systems and pulling them?
That is absolutely the goal. The goal here is to add bolt-on items, or in this case, whether it's the machine learning algorithm or this transformation and graph database. And when I say graph search, this could be part of the system that you already have. If you already have an intranet, whether it's SharePoint or whatever it is, you can provide that functionality within that intranet. So the end user application is really highly specific to the use case that you're trying to do. In this case, this was HR. It could be insurance. It could be anything, really. But yes, the goal is to use the system that you already have, extract the data, and perform analysis on that data. But the system that you already have is still your system of record. Make sense?
So does Unified Viewer use an API to let the other systems?
Yep. Absolutely. APIs, so Pool Party is highly dependent on REST APIs. It's a very solid system in terms of provides robust APIs that you can extract information from Pool Party, but it also can connect with different systems like Drupal and SharePoint. But it also provides, within Pool Party, they call them DPUs, data processing units, that connect to whether it's a SQL server or a MySQL and so on, or XML. You can connect and then transform that data into what you're looking for. So API is one way, looking at the file themselves, or pulling a file from an FTP side and then writing to an FTP side if you needed to. That's also something that can do.
And you're able to do it on your own. You don't have to work with the team from another company.
As long as you have access to the data, yeah, you can do it. Yeah, you don't need anybody else. You need the skills to get this done, but yeah, as long as you have access to the data. If it's an open API, you can do as whatever you want with that data.
Right.
All right? Yes?
You were mentioning before about the tagging.
Yes.
Does the system require you to actually identify specific tags? Does it read? So here you have in your box that has the highlighted text.
Right.
Does it read that and identify and then make those connections, or do you actually have to label that document that has that logo tag
Yeah.
with specific tags? How does that work?
This is really cool. Unfortunately, I don't have a specific demo for this right this second, but this is where the machine learning comes into play. You feed it the basic vocabulary. So think of it as a toddler. This is my best example. Think of it as a toddler. You have to give the toddler at least the basic vocabulary so that the toddler can start understanding you. And then having this base, you can start adding additional terms or additional concepts that are related to what you already know. So what's happening here, and it's hard to see, but you have one term and then you build these relationships. When I say you, it's the machine, and the knowledge engineer can confirm these relationships. So it's a supervised learning way. But when you have the text, these tags are applied automatically. All right, So if there are no other questions, I think we're just about at 1:50. So thank you very much, everybody. Hopefully that was helpful. If you have additional questions, we have a little bit more detail on the use case itself. Some white papers, they're right outside, and I'll be right there too. So thank you.